In this video, I want to find the integral of 1 to 2 of x over x squared plus 4x plus 20. So the goal here is to use u-substitution, but if I let u equal x squared plus 4x plus 20, du is 2x plus 4. But in the numerator, I just have x. So what I want to do is write x in terms of 2x plus 4. So we're going to do that by saying x equals a times the quantity 2x plus 4 plus b. And a should be 1/2 because I want to get x. So far I have 2x. So if I let a equal 1/2, 1/2 times 2x is x. But then I have 1/2 times 4 is 2. So I need to cancel out the 2, which means b has to be -2. So then x is going to equal 1/2 times the quantity 2x plus 4 minus 2. And so that's what's going to be replaced, or that's going to replace x. And so I can split this up into two fractions. So I have the -2 will go on the second fraction. So now there's going to be two integrals. The 1/2 can come outside, and I have 2x plus 4 on top, and then x squared plus 4x plus 20 on the bottom. And then for this integral, I can factor out x squared plus 4x plus 4 into x plus 2 quantity squared, and then plus a 16. On the left side, now we can do a u-substitution, because if I let u equal x squared plus 4x plus 20, du is 2x plus 4. And so that's going to be the top. So 2x plus 4 dx, technically. And because I made a u-substitution, I can change the limits. If x is 1, plug it in here, we have 1 squared plus 4 times 1 plus 20 is 25. If x equals 2, 2 squared plus 4 times 2 plus 20 gives me 32. And so that's going to be du over u. And then minus the same thing on the right. Now, the antiderivative of 1 over u is just natural log of u. Plug in 32, plug in 25, and subtract. And so now we can just focus on the integral here. For that, we're going to make a u-substitution. Let u equal x plus 2. Du will be dx. And so we'll change the limits. If x is 1, u is 1 plus 2, which is 3. If x is 2, u is 2 plus 2, which is 4. So we have the integral from 3 to 4 now. 1 over u squared plus 16 du. And then the natural log 32 minus natural log 25 is natural log 32 divided by 25. Now recall that the integral of 1 over x squared plus a squared dx is 1 over a times the inverse tangent of x over a plus a constant c. For us, we'll replace a with 4. So that'd be 1/4 inverse tangent of u over 4. And then we're going to go from u equals 3 to u equals 4. When we plug that in, we get, when we plug in u is 4, we get 1/4 inverse tangent of 1. And we plug in u is 3, we get 1/4 inverse tangent of 3/4. So now we'll just simplify. Inverse tangent of 1 is just pi over 4. That's 1/4 times pi over 4, which is pi over 16. But distribute the 2 gives me pi over 8. And then we have minus 1/2 inverse tangent of 3/4. Now I can distribute the negative to get 1/2 natural log 32 over 25 minus pi over 8 plus 1/2 inverse tangent of 3/4 as our final answer.